Hello, Advanced Algebra 2. Welcome to the Concept 39 notes. In these notes, we're going to talk about simplifying, multiplying, and dividing rational expressions. So let's look at simplifying rational expressions. So a rational expression is a fraction whose numerator and denominator are non-zero polynomials. So the domain of a rational expression needs to exclude values that would make the denominator zero. A rational expression is in simplified form when its numerator and denominator have no common factors. Now look at this core concept. So simplifying rational expressions. So that says let A, B, and C be expressions where B does not equal 0 and C does not equal 0. So we have A times C over B times C. Notice that we can divide out our values, our C values in the numerator and denominator, and we will just be left with A over B. Now look at some examples. 15 over 65. You have simplified fractions for a long time in your math career. So we can divide both of those by 5 and it would simplify to 3/13. Now look at the rational expression example. 4 times x plus 3 over x plus 3 times another x plus 3. So one pair of x plus 3's will divide out and we'll be left with 4 over x plus 3. Now notice in the box it says you can divide out common factors in the second expression on the right. But notice the third expressions we cannot divide out. So simplifying a rational expression usually requires two steps. First, we're going to factor the numerator and the denominator separately. Then we'll divide out any factors that are common to both the numerator and denominator. So here's an example. We have x squared plus 7x over x squared. In our numerator, we can factor out a greatest common factor of an x. In our denominator, we can think of x squared as x times x. Now we can divide out our single x terms in that second expression. And then what we'll have left is x plus 7 over x. Notice we cannot divide those x's out because our top x is connected in an expression with the 7, and that changes it. So it is not the same thing as just a single x. All right, let's try example 1 now. So the first thing we need to do is factor our numerator and denominator if possible. Our numerator is a quadratic, so the two numbers that multiply to give us negative 12 and add to give us negative 4 are negative 6 and 2. Now look at the denominator. We've got a difference of squares, and so that will factor as x plus 2 times x minus 2. Now you're looking for these polynomial expressions that are exactly the same. So the x plus 2's will divide out, and we'll be left with x minus 6 over x minus 2. You can drop the parentheses. The only time you need a parentheses around an expression is if you need to separate it from something else, another expression or a value. Now we need to go ahead and set our domain rule. So we're going to look one step back before we simplified, before we divided out the terms. And we want to make sure that we exclude anything that would make the denominator 0. So if we put a 2 in there and subtracted 2, that would give us 0 multiplied and our denominator would be 0. So we need to exclude that, and the same for negative 2. So again, to determine what exclusions we need for the domain, you're going to look one step back or back to the point in your rational expression before you simplified and divided things out. Because even though in the final answer we don't see the x plus 2, it is still a part of the problem. Let's do some more practice. So notice on A, we are all factored in numerator and denominator, so we can go right to dividing out. We can divide out our x plus 1's, and we'll be left with 2 over x plus 3. We can drop all parentheses, and now let's establish our domain rule. So we go one step up before we simplified, and the numbers that would make either of those expressions 0 are negative 1 and negative 3. So our final answer is 2 over x plus 3 with a domain exclusion of negative 1 and negative 3. Now let's look at b. Do you see there's some factoring to do in the denominator? So we'll have x plus 4 over x plus 4 times x minus 4. Our x plus 4s will divide out. Anything divided by itself is 1, so we'll have 1 in the numerator over x minus 4. Look one step back to see what your domain restrictions need to be, and that would be -4 and +4. Now, if you look at C, there's no factoring to do, and there's no dividing out. So sometimes you'll have a rational expression that is already in simplified form. So we'll just go ahead and move on to the domain rule. X cannot equal 0 and -2. Now, finally, on D, we have a quadratic in our numerator. Oh, sorry, I'm going to change this problem because we've already done it. So go ahead and write this problem down in your notes. X squared minus 2x minus 3 over x squared minus x minus 6. So we have two quadratics to factor. So our top will factor as x minus 3 times x plus 1, and our bottom will factor as x minus 3 times x plus 2. Our x minus 3's can divide out, and we'll be left with x plus 1 over x plus 2. Look one step back to figure out your domain exclusions. So we need to exclude +3 and -2 because those values would make our denominator 0. Now the rule for multiplying expressions is the same as the rule for multiplying numerical fractions. You multiply numerators, you multiply denominators, and you write the new fraction in simplified form. Now, similar to rational numbers, like fractions, 2/3, 3/5, rational expressions are closed under multiplication. A set, and in this case rational expressions, is closed under an operation if performing that operation on members of the set always produces a member of the set. So performing multiplication on a rational expression will always produce a rational expression. Now look at the core concept below. So this is just an example. First of all, property, then an example of multiplying rational expressions. So we have a over b times c over d. We multiply numerators together, denominators together, and we get ac over bd. So in the example, we multiply 5x squared times 6xy to the cube and get 30x cubed y cubed all over 20xy cubed. Then we simplify, so we divide out common factors in the number and also the variables. And then notice for our domain rule, since we had x and y in our denominator one step before we simplified, we need to specify that x should not equal 0 and y should also not equal 0 for our domain rule. All right, let's look at example 2 and multiply some rational expressions. So we're going to multiply numerators together and denominators together. So 8 times 7 is 56. X cubed times x to the 4th is x to the 7th. Y times y cubed is y to the 4th, all over 8xy cubed. Now we'll divide out our fraction. So 56/8 divides down to 7. X to the 7th divided by x will leave us with x to the 6th. Y to the 4th divided by y to the 3rd will leave us with the single y. And for our domain, we had x and y in the denominator one step before we simplified. So we have to say that x cannot equal 0 and y cannot equal 0. Because if we plug those values in, then that 0 will multiply by everything else and make our denominator 0. All right, let's look at B. We have a little bit more complex expressions to deal with. So let's start by factoring all our numerators and denominators if we can. So in our numerator, first numerator up on the left, we can factor out a 3x. We're left with 1 minus x. And then in our denominator, that will factor as x plus 5 times x minus 1. In our numerator on the right, this will factor as x plus 5 times x minus 4, all over 3x. Now, with these expressions, I am going to divide out any numerator with any denominator. So rather than writing them all together, then dividing out, I'm just going to imagine them all together. So notice our 3x's will divide out, our x plus 5's will divide out. Now look at the numerator on the left, the 1 minus x. I'm simply going to commute that expression and write it as negative x plus 1. Now I can factor out a negative 1 from that expression, and look what happens. So when I factor out the negative, I'm left with x minus 1, which now is the same as my denominator. So I can now divide out my x minus 1's, and I'm left with negative 1 times x minus 4, or negative x plus 4. And then finally, for our domain rule, we're going to look all the way up before we simplified and make sure that we exclude negative 5, positive 1, and 0, because those are all the values that would make the denominator expressions 0. All right, I am going to conclude the Part 1 Concept 39 notes here and pick it up in Part 2 to do another couple examples of multiplying and then talk about dividing.